Write down the problem. The plan and elevation of a 3-story RCC school building. RCC school building. So the building is located in seismic zone 5. The building is located in seismic zone 5. The type of soil encountered is medium stiff, and it is proposed to design the building with a special moment resisting force frame. Resisting frame. Resisting frame. The intensity of dead load is given. The intensity of dead load is 10 kilonewton per meter square, and the floors are the floors are having live load of 3 kilonewton per meter square. Okay, so determine the seismic load on the structure. Determine the seismic loads on the structure. So this is the question. So here the plan and elevation of a 3-story building that I'm going to draw it. The plan and elevation of a 3-story RCC school building. So please note down, this is school building as shown in the figure. The building is located in seismic zone 5. This is important part. The type of the soil is medium stiff. This is also important, and it is proposed to be designed building with a special moment. This is also a special moment resting frame. This is also very important. The intensity of dead load is 10 kilonewton. This is the load that the building is having. The dead load overall they have given. Actually, we have to calculate dead load is given as 10 kilonewton per meter square. That is for the problem. They have directly given the dead weight, but actually we have to calculate how many columns are there, how many beams are there, how much is the slab area, everything to get the exact dead load. But here, for the purpose of simplification, they have given the weight of the dead load, and the floors are having a live load of 3 kilonewton per meter square. This is also important. Determine the seismic load onto the structure. So what happens? Seismic load you have to calculate onto the structure. That is the base shear that you have to calculate. So all these points that I have underlined are the important points to be carefully understood, and you should open the code book parallelly, and then you can do this solve this problem. I think everyone take the hard copy of the code book. Don't use the soft copy. Take the hard copy. Keep it side of you whenever you're doing these kind of problems, which will be useful for you to understand the code properly. Otherwise, if you use this one, could be it is not suggestible. Okay, so we'll go to the solution of this one. So first, what we have to do. So first, you write down the parameters, that is design parameters. First, we have to find out the basic formula is what we know that VB equals to AH into W. This is the formula that we have seen in the code book. Okay, so everybody open the code book and see this is the one. So first we have to calculate the AH value. So AH value means what we have to find out what is the formula for the AH as per the code book.
Capital.
So this is the formula, right? So SFG is 1. ZW2R into SFG. This is the formula. ZW2R into SFG. So Z value is given over here. Seismic zone. So what is the Z? It is zone 5. So for zone 5, in the question it is given as zone 5. So for zone 5, what is the Z value? For zone 5, what is the Z value? Please see the code book and tell me the value. It will be given in the table. If you open the code book, it will be given in the table.
.36.
0.36. Yes. What is the table number?
Table 2, sir.
In table 2, you are having this value of Z values. You are having Z values in table 2. So it is given as 0.36. In table 3, it's not table 3. 0.36. Then what is the next important parameter? So here Z value is there. Then what is I value? What is I value? I is what in this equation? I is importance factor. Importance factor. And from where do you get this I value? Important factor in the code book. Everything will be there in the code book. We have to find out the way there, where the page number 9, you can see it is given clearly. You have to search over there for 1.5 for the typical and lifeless structures, or it will be given in the table also. You go down, important table will be there. You go there and you can see that. So for all critical and lifeless structures, the spool is very important. So for this one, the I value should be taken as 1.5. It's an important structure, right? Then I value, after I value, what is R value? R is what? Response reduction factor in IS 1893. And R value also is given in the table. So which table and what is its value? So here you can see that in 2016 code only, the code book is IS 1893 20 part 1. Part 1 2016. This is the code that you have to use. Okay, 2016. This is the code. So go to that code. In table 9, R values will be given, and in the question it is given as special moment resting frame. So the special moment RC frame is the value for R is 5. So special moment resting frame that is SMRF. You can say that SMRF, special moment resting frame. RC building with special moment resting frame. The value is given as 5 in table 9. Table 9. And I values are important factors that are there. They are given in table 8. And Z values are given in table 3. So any earthquake calculation, first we have to find out AH value, and these values for any type of structures throughout India, you can get the values and you can calculate easily. Now, what is SA by G now? SA by G. So this depends upon the time period of the structure. So I have to give you the diagram first. I have not given this plan diagram. So draw this plan. It's a simple 2 by 2 grid with columns over here 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. Each bay is 4 meters. It's a square one. So you will have the same earthquake force in both the directions. This is the plan, and elevation is, this is your elevation. So you're having uniform distributed load over here. Here also uniform distributed load on the floor. There also uniform distributed load. The height of each floor is 3.5 meters. 3.5. This is the elevation. This is the plan. Okay. So this is the plan is important for you to calculate the time period, so that based on time period you can calculate SFHG value. Now, how this time period is useful and what is the formula that you have to use is there in the code book. So time period SFHG value will be calculated based on the time period. So here, if you go back here, the time period calculate SFHG. First, you need to calculate the time period, which is given in clause 7.6.2, page number 21. So there you have to go. So here we'll calculate the time period now. The formula for the time period is given over here. So the time period formula over here is given as T equal to 0.09 H by 2T. So this is the formula that you have to use, where H height of the structure H is how much? You see the plan 3.5, 3.5, 3.5, that is 10.5. So it is 10.5 meters, and base width D. This is the D is the base width. Base dimension of the building at plinth level along the considered direction of the earthquake shaking. So here in the figure, if you see, this is your base. So this is your base width D. Here in this case, base width D is symmetrical about both the directions. So normally what happens is that if there are rectangular shaped buildings like this is a rectangular shape, right? Here D is not same. Here D value is different can see this is D value and here is D1. So the value on the one face is different from the other face, D value. So what happens, the time period, what happens in this case, you will be getting two time periods. You can say that time period for D, and I can say T1 I will take for D1, root D1. So this is one time period and this is one time period. So here in this case, the base shear, that is BB equals to AH into W, you will be having base shear X and also base shear Y, AH into W in two directions. If I say this is my X-axis and this is my Y-axis. So two two base shears you are going to get. So it is going to oscillate in one direction and also the other direction also it's going to oscillate in two different ways. So here, if it is a rectangular building, the time periods will be you will be getting two time periods and you will be getting two base shears. These two base shears. This is one along X and Y. But in our case, the present scenario, only we are having the base width equal in both the directions. So I'm going to calculate only one period, that is h equals to 10.5 meters and here d is equals to 8 meters. So if you substitute, what is the time period now? So what is the time period? 0.334 seconds. So once you get this value, go to the code book, the time period what you have calculated. Go through the code and go to the SFHE, that curve, whatever is there. Here in the code, you have to go to the code book, page number 13. This SFHE curves are there, which is response vector. There are two curves, the static method and the response vector method. This is for the static method. If we go to the static method, here you can see in the first curve, you can see you have to see which one, whether it is a medium soil or hard soil or soft soil. That is given in the question, right? In the question it is given, it is a special notation. It's a medium stiff soil. It is given in the question over here. It is a medium stiff. Medium stiff means based on that you can see the code book. The type 2, you are having three types. Type 1 is rock and hard soil. Type 2 is medium soil. Type 3 is soft soil. So in the question it is given as medium soil. So you have to go to the type 2. So type 2 means the second curve. So in the second curve, so this curve, you can see that this is the curve. For the static method, I'm using this curve, and type 2 soil means this curve. Now, what is the time period that we got? 0.334. That is, it is going to be somewhere over here from 0 to 1. That is 0.3. So if it is half, it will be half over here, and 0.3 is somewhere it will come over here. So directly, if we go straight up, it is going to be 2.5. The value will be 2.5 over here. So here the rate of the time period t will be given as, sorry, SFHE value will be given as, SFHE value will be given as 2.5. Based on the time period we have identified this SFHE. So finally we got all the values. You can tell AH value now. You can get AH value. Substitute all the values that we have identified from the code book. That is, Z value is 0.36, I value is 1.5, 2 into R value is 5, and SFHE value is 0.33. Not 0.3, SFHE value is 2.5. So from this, what is the AH value? 0.135. So So 0.135, you got the H value. Now the W part. This is weight of the seismic weight of the structures. So here we in the problem it was given that the intensity of dead load is 10 kilonewton per meter square. And live load is given as 3 kilonewton per meter square. So to calculate the seismic weight, dead load is 10 kilonewton square. These two are given, so you have to calculate according to this. So the floor area is how much? If you see the plan, it is floor area is how much? What is the total area of the floor? So if you look into the plan of yesterday's problem, that is 4 meters, 4 meters, 4 meters, 4 meters. So this is 8 meters. So it is 8 meters. So it is going to be 8 into 8, that is 64 meters square. Is the floor area. Okay. So now the point over here is for the live load, what is the percentage of seismic weight should be contributed? That is what is that it can take. So everyone open the code books. Everyone open the code books and tell me what is the percentage of live load to be considered. What is the percentage of live load to be considered? Percentage of live load to be considered in calculating the seismic weight. So here the total seismic force, seismic weight is W equals to sum of all the forces. Say WA. That is this total force equals to sum of all the forces. Here W sigma W, where W is the total load for all the force, including the dead load and percentage of live load. Right, sum of dead load plus. I'm going to keep a question mark over here. What percentage of what should be the live load percentage? So dead load we can calculate. You know the dead load is given as 10 kilonewton per meter square, and you know the area of each floor. So 10 into 64, it is easy. 640 kilonewton is the force for the dead load for each floor. But for the live load, it is given as 3 kilonewton per meter square. But for 3%, 3 kilonewton per meter square, what is the live load percentage considered as per the code book? So to check that value in the code, the percentage of imposed load to be considered in calculating the seismic weight, which is given in table 10. So in that table, if you see that up to and including 3, it is 25%. Up to and including 3, it is 25%. Please everybody go to that particular point, table 10, page number 20. Page number 20. So in that page number 20, table 10, up to and including 3 kilonewton per meter square, the percentage of live load to be considered is 25%. Okay, so 25%. Above 3 means that is above 3 kilonewton per meter square, it is 50% to be considered. So here the live load is 25%. So 3 of 25. So as per table, table 10, live load percentage should be considered as 25%. Okay, so 3 of 25, we have the live load as 3 kilonewton per meter square, 3 into 25 by 100. What is this value? How much it is? 0.75.
0.75.
0.75 kilonewton per meter square. So this is the live load percentage to be considered when you are going through 3 kilonewton per meter square, whatever is given the problem is for the problem. So here is that value. Now let us calculate. This is 0.75. 0.75 as live load that we have taken, and now we will calculate the total live load for each floor. So here you can write seismic weight contribution from one floor. So for one floor it is 64 is the total 64 is the total area into what is the 10 what is the live load intensity 10, right, plus 0.75. So that is going to be 10.75 into 64. 10.75 into 64. That is 688. 688 kilonewton is the total weight for each floor. Okay. So here, how many floors are there for our building? If you go to the elevation, we have how many floors? We have 3 floors, right? So instead we have this elevation diagram that I have given. So each floor head is 3.5, 3.5, and 3.5. And we have how many floors? This is the UDA, total weight. So 1, 2, 3 floors are there. So for 3 floors, you multiply with 3 floors. That is going to give you. Actually, the roof, there will not be any live load. Only for first and second floor, live load will be there. For the roof, it will not be there. Or for roof, generally, the live load is taken as 1.5. So for the present scenario, that is not a matter. So we'll consider only the roof, only dead load on roof, and the remaining we are going to consider the live load. So we have 2 floors. For 2 floors. It is going to be 2 into 688. That is 1376 kilonewton. And for roof, we are only considering directly. We are considering directly 64 into 10. Only the dead load weight, that is 640 kilonewton. So the total weight of here is going to be 2016. Right? So this is the total seismic weight W. We have written this W is equals to sigma WI. This value is 2016. So W equals to 2016 kilonewton. Now the total weight is there, and we have the AH value. So finally, what is the base shear? So it is a simple formula. Therefore, design base shear VB equals to AH into W. This is the formula, right? So as per which clause is this formula? As per which clause is this formula? Now, can you tell me the formula as per which clause is this? Tell me the clause. So why I'm asking is that at least you will scroll the code book and check where the value is and where the equation is, because during the exam you have to quickly scroll it and check where the code is, where the values are in the code. So where is this value? VB is equals to AH into W. I think we have gone through each and every point, and I told you the clauses also at that time. Yes, quickly tell me the clause numbers. Tell me the clause number.
7.2.1.
7.2.1.
2.1.
Which code you are looking into?
2016 IS 189.
7.2.1. Okay. So the design lateral force building shall be designed for the design lateral force VP is given by VP equals the AH to W. And it will be estimated as per 6.4.2 and W as per 7.4, and it is given in page number 17. It is given in page number 17. Okay. So as per the clause 7.2.1, page number 17. So AH value we found out as 0.135 into total seismic weight is 0.16. So this is the base force that is going to come onto the structure. It is going to be 272.16. 272.16. kilonewton. So the force that is coming and striking the structure is 274 for each floor. Okay, it is going to come and strike over here at the base of the structure, that is 22.16 kilometers is the force. Now this force should be what will be the force distributed to the first floor, second floor? What will be the force that will be transferred to the first floor, second floor, and third floor? So this force will be distributed to all these three levels. So how much is that value will be there? So for that, in the code we have the clause. We have to calculate it. I will show you. So distribution of the forces. Here it is given in page number 21, page number 21, clause 7.6.3. The design base shear will be computed in clause as per clause 7.6.1 shall be distributed along the height of the building and in plan at each floor level as below. So vertical distribution of the base shear to different floor levels is given. Here the design base shear VB computed is as per clause 7.6.1 shall be distributed along the height of the building as per the following expression. So it is given in page number, the expression is given in the page number 23. If you go there and see, the expression is there in the page number 23, and it is given as Qi equals to Wi Hi square divided by sigma j equals to 1 to n and Wj h j square. So this is the formula that is given, where Qa is what? Where Qa is the design lateral force. Lateral force at floor I, and Wi is what? Seismic weight of floor I. Weight of floor, height floor, and Hi is the height of the floor. Height of the floor I measured from base. Okay, and N is what? Sigma j equals to 1 to n is there. That n is nothing but number of stories in building. So these values are there. According to this, we can distribute the force. Now here how to distribute that, we can do this in the tabular form. It is quite easy only, nothing to get confused with the formula. I'm going to break this formula as a tabular format, and it will be quite easy. So you can write over here. Initially, you write in the table, you write story level. So how many stories we have? We have 3 stories, starting with reverse direction 3, 2, 1. Okay. Then in the formula it is given as Wi. So Wi is the weight of each floor, right? So weight of the third floor that we have considered is 640, and for the second floor we have considered is 688, and 688 is the total weight, right? Then you can break this one into HI in meters height of the floors. The third floor height is sum of all the forces, sum of all the heights, that is 3.5, 3.5, 3.5, that is 10.5. And for the second floor, if you deduct 3.5, it is 7. And for the first floor, it is 3. Okay. Then Wi HI square in the formula it is given. So it is you have to just multiply this one into this one into this one into this. You will get the value. You will get one value. Then it is given as Wi HI square divided by sigma Wi HI square. This is the value. So sigma HI square means we have to add over here sigma Wi HI square. You have to add over here, and that divided by these values, we'll get a fraction of it. So then after that, the lateral force will be there, that you have to multiply with VB. That is whatever value you are getting. So here these are the values, and finally the last column is lateral force VA at ith level along the x direction or y direction. That value should be multiplied. So the formula here is WH square divided by this sum of those W J plus H J square into VB. So what is the VB we got? 272.16. So 272.16 into this 0. Whatever value you will get over here in this column. So whatever values you are going to get, this should be multiplied with base year VB. VB value is 272.16 we got kilonewton. So if you multiply that, you will get the values at this third level, second level, and first level. Okay, so this is the table. So here you can write at VI. The VI is nothing but the lateral force VI at each level, at level 3 to 1. We'll go through this. We'll complete this problem. Okay. So calculate this value WI HI square. What is the value, and calculate and tell me. So we have 10 minutes of time. We'll complete this problem. 10 minutes. So quickly tell me what is the value. We have 10 minutes time. Everybody do the calculation part. It's quite easy. It is given on here only. WI/HI square. You have to multiply this and tell me. And the total seismic weight should be divided for each floor. So what is the value WI/HI square? What is the first value? Please somebody give me the answer for this. What is the first value WI/HI square?
70560.
Except Prakash. All the time I will hear your voice and I want to hear some new voices. And anyone is logging in with the phone and operating the phone, I suggest them to please log in with the laptop. Open your. So anybody else can tell me the answer. Yes, quickly please tell the answers. We have to go and complete the problem. We have to fill this table. We have to show we have only 8 minutes time. Yes, somebody tell me the answers, please. Amarnath? Amarnath 30. What is WI/HI square value? Calculator లేదా ప్రాబ్లం ఉంది కదా ఉన్నారా అసలు సిస్టమ్ ఉన్నారా? Are you listening to my class? Kaushik, are you there? Vivek, are you there? Gayatri, are you there? I think you people are not there. These people are not there. They are not responding also. Yes, are you there, Gayatri?
Yes, sir.
What are you doing? You are not responding to my. You are not telling the values. Can you calculate and tell me what is WI/HI square? Vivek, Kaushik, and Amarnath, are you people there? So what is WI/HI square? Please tell me. It is only 5th class calculation.
Sir, 112700.
112700. How you got that value? It's simple. WI 640 into 10.5 square. How can you get that? That is the
Summation,
total
sir.
value. Total. I'm not asking the total one. Individually, what is first one? 640 and 10.5.
70560.
70560. Yes. So that is the value. Right. 70560. The next one. 33712. and third one is
8428.
8428. Okay, and coming to this next column, we divide the total you got 112,700. So that value should be divided over here. So that what is the fraction that you are going to get? What is the value that you are going to get over here? WH square divided by
0.626.
0.626. Somebody please, others also please look into these values and tell me, Gunashankar, what is the next value?
0.29.
0.29. 0.299. And the next value?
0.074.
0748. Yes, good. So these are the values that we got. Now, what is the value that VI is? What is the VI value? What is VI value? The first value we have to multiply with 272. It is 272.16 into 0.626. That is the value we have to multiply with. Then you will get the value. So how much is that? 272.16 is the base share that we got. That base share should be distributed to all these levels. So these are the coefficients here. These are the coefficients, right? So for these coefficients, you are multiplying them. What is the value that you will get?
$170.37.
170.37. 170.37. And what is the next value?
Uh, 81.37.
81.37. What is the next value? Niharika, are you there?
Sir,
So what is the next value? What is the next value? So simple multiplication, you have to multiply with 0.0748, whatever is there
20.
over here.
Sir,
20.33. 20.41 you will get. Okay, so these are the values. So if you add these values again, it will be this value only. If you add, it will come. All these three values, if you add, it will come. So now if you go back to the diagram, that this one, the force for the first floor 20.140.41, right? And for the second floor we got us 81.38, and for the third floor we got us 70.37. So these are the forces that are distributed to each floor. These are the forces that are distributed to each floor. This is how we have to calculate the distribution of forces after calculating the base shear. After calculating this base shear, again, if you add all these three, 170.37 and 81.38 and 20.4, will get the base shear. Okay? So this is the problem, and this is how we have to approach for these kind of problems. And now, if you have anything to ask or anything to say, we'll discuss, or we'll end the session only. Anything to So we'll end this session for today, and we'll meet in the next class. Thank you.